The last star in the observable universe will finish burning approximately 100 trillion years from now, going dark so quietly and so far from anything that no instrument will record the moment, and the universe will simply continue without it. That fact belongs to a scale of time so remote that the mind does not hold it easily, but it holds it nonetheless, the way a stone holds warmth after the sun has moved on. There is a story in that vastness, and it moves slowly, as the largest things always do. Before that story begins, there is a small thing to say clearly and only once. The Earth will not be here to see any of it. Long before the last stars dim, long before the sky empties of its familiar lights, the sun will have swollen and brightened and consumed the inner planets, and the world where human beings once watched the sky will be gone. What follows imagines another place, a quiet world, something like Earth, standing in for a world, watching the whole long arc of the universe arrive overhead across the full span of cosmic time. That world is a convenience, a place to stand, and once that is understood, it need not be said again. So there is a world, and it sits beneath an open sky. The ground is dark and settled, the kind of ground that has been cool for a long time, not dramatically or miserably cold, simply at rest. The atmosphere above it is clear in the way that very dry air is clear, without haze, without weather moving through. Stars are visible. They are numerous and bright, the way stars appear when there is no competing light below, when the sky has full possession of the dark. The Milky Way stretches overhead in its slow diagonal, a river of accumulated light made from hundreds of billions of individual fires burning at distances that blur them into a single soft band. From the ground of this world, it looks the way it always has, the way it has looked for billions of years already, patient and still and immense. The universe at this moment is burning. That is the simplest thing to say about it. Hydrogen gathers under its own weight in clouds that span many light years, compresses inward over millions of years until the pressure at the center becomes intense enough to fuse atoms together, and in doing so releases energy in quantities that last for millions or billions or trillions of years, depending on the size and character of the star. This has been happening since shortly after the universe began, roughly 14 billion years ago, and it is happening everywhere simultaneously, in numbers that resist direct imagination. There are estimated to be somewhere between 1 and 200 billion trillion stars currently burning across the observable universe, a number which is better felt than understood. That burning is ongoing. It is also finite. Each star is using something up, slowly and extravagantly, or slowly and carefully, depending on its nature, but using it nonetheless. The hydrogen does not replenish itself. The galaxies are not generating new fuel at the rate they once did. The period of greatest stellar abundance has already passed, somewhere in the Middle Ages of cosmic time, when star formation was at its height and galaxies blazed with the light of young suns igniting in rapid succession. The universe has aged past that peak now. It is not old in any terminal sense, not yet, but the great era of stellar proliferation is behind it, and what remains is the long, slow evening of stellar life, the era that astronomers sometimes call the stelliferous era, meaning simply the age in which stars exist. That age is still very much underway, but it is moving, as all things move, toward its conclusion. From the quiet world beneath its open sky, none of this is apparent yet. The stars are simply there, overhead, in the numbers they have always occupied, burning in the same patient way. The light arriving at this surface left its sources years or decades or thousands of years ago, depending on how far each star sits, and so the sky is always a picture of the recent past, a mosaic assembled from slightly different moments, all arriving simultaneously at this one still place on the ground. The air above the ground is cold in the way that night air is cold, not hostile, not remarkable, simply the natural temperature of a surface no longer receiving direct light. The stars do not warm it. They are too distant for that, and their warmth disperses so completely across the space between that nothing arrives except the light itself, the long-traveled photons that carry no real heat by the time they reach an eye or a surface, only information. The sky is full of information. It has always been full of information. The universe is very old, and it has a great deal longer to go. The story that follows moves through that remaining time in broad strokes, era by era, each one longer than the last, each one quieter. The world beneath the sky will be there for all of it, watching, its ground cool and still, its atmosphere clear, the stars overhead doing what they do, until they do something else, and then something else again, and then, finally, nothing at all. For now, the stars are burning, and the sky is full of them, and the night is early. The light that fills the sky in this era comes from everywhere at once, not from a single blazing point, but from the accumulated burning of hundreds of billions of stars, each one a furnace running on the simplest fuel in the universe, hydrogen, the most abundant element there is, pressing inward on itself under gravity, until the pressure at the center grows hot enough to fuse atoms together and release energy outward, a balance held for millions or billions of years between the weight of a star falling in and the light of it pushing out. On the imagined world, the night sky is not dark, it is layered. Closer stars resolve into distinct points of white and gold and faint blue, and behind them, the galactic band arches overhead like a river of unresolved light, millions of stars too distant to separate, their glow blending into a continuous pale luminescence that brightens the horizon even when no moon is present. The ground below catches some of that diffuse brightness. Rocks hold a faint gleam. Still water mirrors the band of the galaxy in long silver ribbons. Even the deepest shadow here is not truly black. There is always a little light coming from somewhere, because everywhere one looks, something is burning. This is the era astronomers call the stelliferous, from the Latin word for star-bearing, and it spans an almost incomprehensible length of time, from the first few 100 million years after the universe began, all the way to roughly 100 trillion years from now, a number so large that the current age of the universe, itself nearly 14 billion years old, fits inside it more than 7,000 times. The imagined world sits somewhere in the later portion of this span, already well past the peak of star formation, past the time when the galaxy was most actively building new suns. But the inventory of stars accumulated over those earlier epochs is still enormous, still burning, still visible in every direction overhead. Stars are born in the cold and the dark, which is part of what makes it easy to forget they are being born at all. Great clouds of gas and dust, floating in the spaces between older stars, slowly thicken over millions of years under the gentle pull of gravity. A cloud collapses inward, its center growing denser and hotter, until a new pressure equilibrium is reached and a star ignites. Not with a single moment of ignition, but with a gradual brightening, a warmth that builds and stabilizes and then simply continues, sometimes for a few million years, sometimes for tens of billions. From the imagined world, none of this process is visible in real time. The birth of a star happens too slowly to observe and too far away to distinguish from the steady backdrop. What is visible is only the finished product, the sustained glow, the light that has already been traveling for years or centuries or longer before it finally arrives. A massive star burns extravagantly. It tears through its hydrogen fuel in a few million years, a brief and brilliant life compared to the age of the cosmos. And when it exhausts that fuel, it expands into something enormous and red before its core collapses, and the outer layers blast outward in an event so energetic that for a few weeks the explosion can outshine the entire galaxy it lived in. The material thrown out in that blast does not disappear. It seeds the surrounding gas with heavier elements forged in the star's core, carbon and oxygen and silicon and iron, atoms that did not exist in the early universe, and that will eventually find their way into new stars and into the planets around them, and into the ground of the imagined world, and into everything that walks or stands or rests upon it. The sky overhead is the record of all that recycling, all those generations of stars giving their substance back to the medium they formed from, so that the next generation can form in turn. Smaller stars burn more slowly. A star somewhat smaller than the Sun may run for 10 or 20 billion years before it begins to wind down, swelling gently into a cooler, larger form before shedding its outer layers in a slow, luminous cloud and leaving its dense, hot core behind. Stars smaller than that last even longer. The inventory of stars in a galaxy is not static. It is a population with a range of lifetimes, the massive ones flaring and dying quickly, while the smaller ones persist quietly through era after era, barely changing, sipping at their fuel with a patience that resists description. From the imagined world, the galaxy appears to turn. Though that turning is so slow, it registers not in any single sky, but only across millions of years. The positions of familiar groupings drifting imperceptibly, the arms of the great spiral rotating like a wheel, too large and too unhurried to feel as motion. And yet it is motion, and it carries the imagined world along with it through regions of greater and lesser density, past the afterglow of old stellar explosions, through faint wisps of nebula that catch the light and scatter it in soft colors visible only over long, slow hours of looking. The mood of this era is warmth. Not the sharp, aggressive warmth of something very close, but the deep, ambient warmth of being surrounded on all sides by fire at a great distance, the way a landscape can feel lit and golden even when the source of the light is already near the horizon. The imagined world basks in that ambient glow. Its oceans, if it has them, reflect it. Its atmosphere diffuses it. Even in winter, even on the side turned away from its own sun, the sky is not empty, because the galaxy is always there. A constant, diffuse presence overhead, burning in every direction. This will not last forever. The gas available to form new stars is not infinite, and the rate at which new stars are born has already been declining for billions of years, a gradual tapering of supply and formation that will continue until the remaining raw material is either locked up in stellar remnants or too thin and cool to collapse into anything new. The era of star formation will not end abruptly. It will taper the way a fire tapers when the fuel is nearly gone, not going out all at once, but burning lower and lower and lower still. But that tapering is still far ahead. In this moment, across this sky, the stars are present in their hundreds of billions, each one a sustained reaction between gravity and light, each one contributing its small measure to the total brightness of the night. The imagined world receives all of it, the ancient light of old stars and the newer light of stars only recently arrived at stability, all of it arriving simultaneously from different distances, all of it mingling overhead into the soft, continuous, unhurried glow of an era that has not yet learned it is ending. The galaxy turns. The stars burn. The imagined world rests beneath them in the long, warm middle of a story that will take a very long time to reach its close. And then, slowly, the story begins to find its way toward an ending. Not abruptly. Nothing in the universe at this scale moves abruptly. The change is so gradual that no single moment could ever be named as the turning point. No particular night would look any different from the one before it. But over stretches of time so vast, they resist any comparison to human experience. The sky above the imagined world begins, almost imperceptibly, to thin. The largest stars have already been gone for an immense span. The great blue-white giants that once blazed at the outer edges of endurance burn through their fuel in tens of millions of years, brief lives, by the measure of what follows, and collapsed or scattered their material back into the galaxy long ago. The medium stars, The ones that burn with a steadier and more patient fire have had their turn as well. They swelled in their old age, brightened briefly into red giants, and then shed their outer layers in slow, luminous clouds, leaving behind dense, cooling remnants in the dark. The galaxy has already lost much of its drama. What remains burns quieter, more carefully. What remain, in the deepest stretches of the era of stars, are the red dwarfs. They are not impressive to look at directly. A red dwarf produces so little light compared to stars like the Sun that, seen from any meaningful distance, it appears as little more than a dim reddish point, easy to overlook in a crowded sky. But this frugality is precisely what makes them extraordinary. Where a star like the Sun burns through its hydrogen fuel over the course of roughly 10 billion years, a red dwarf can sustain itself for hundreds of billions of years, some of them for trillions. They are the universe's most patient fires. They do not blaze, they smolder. The imagined world sky, in these late chapters of the Stelliferous Era, holds fewer bright points than it once did. The brilliant ones are gone. What hangs overhead now is a quieter array, a sky of embers rather than flames. The remaining stars clustered in shades of deep orange and dim red, each one a slow and careful burn, each one drawing on its reserves with an almost geological patience. The constellations, if any mind were present to trace them and remember them over sufficient spans of time, would shift and dissolve as the stars within them gradually wink out, one by one, over intervals that make the previous eras look brief. Red dwarfs sustain themselves through a slightly different internal process than larger stars. In a more massive star, the fuel in the core burns without mixing much with the hydrogen in the outer layers, so that once the core is spent, the star's life is effectively over regardless of what remains above. But in a red dwarf, the entire interior circulates slowly, like a gentle, sustained stirring. Fresh hydrogen from the outer layers makes its way down toward the core over time, and spent material rises and disperses. The whole star participates in the burning. Nothing is wasted. Every available measure of fuel is eventually consumed, and only when nearly all of it has been processed does the fire begin to fail. This means that a red dwarf dies slowly and quietly, without the drama of a larger star's ending. There is no sudden swelling into a giant, no bright shedding of an outer envelope, no dramatic final moment. The fire simply becomes fainter over an almost incomprehensible duration, dimming from dim to dimmer to the threshold of darkness, and eventually crossing that threshold so gently that the moment of extinction is nearly indistinguishable from the long approach to it. On the imagined world, this would register not as darkness descending, but as a kind of thinning. The sky would remain recognizable for unimaginably long periods. There would always be some light, some ember somewhere overhead, some patient red point holding its position in the dark. But the spaces between those points would grow wider. The soft, ambient glow that once made the night feel inhabited, continuous, full of distributed warmth, would pull back into isolated pockets. The imagined world would rest beneath a sky that felt increasingly sparse, increasingly quiet, like a room from which furniture has been gently and steadily removed, one piece at a time, over so many years that no single removal is ever noticeable. It is a kind of loneliness, perhaps, though without any mind present to feel it. It is simply a condition. The universe at this stage has not ended anything with violence or urgency. It has only allowed its fires to finish what they were always going to finish in the time it always took them to do so. The last red dwarfs burn on for durations that exceed everything that came before them. The age of the sun, the age of the galaxy, as it was when light was plentiful and the sky was thick with stars. The entire preceding history of the Stelliferous Era. All of it folds into something that looks, from the vantage of the final red dwarf's lifespan, like a brief beginning. These last fires are the longest chapter of the story of stars, and they are written almost entirely in patience and in dim, persisting warmth. And then, at last, the last one dims past the point of recovery. There is no sound to accompany this, no shudder passes through the universe. The star simply crosses from barely burning to no longer burning, and the sky above the imagined world, which has been growing quieter for longer than any previous era lasted, goes fully, completely dark for the first time. Not the darkness of a cloudy night, not the darkness between stars in a sky that still holds stars. A different kind of dark altogether. The era of stars has reached its end. The imagined world sits beneath that new dark, the way a landscape sits beneath the moment after a long rain stops, when the sound of water has finally, fully ceased, and the silence that follows is not empty, so much as complete. The warmth that was always present somewhere overhead, that red and patient warmth that outlasted everything else, has released itself into the universe and dispersed, and what is left is stillness of a kind the cosmos has not yet experienced. The galaxy continues to turn, but it turns now without fire. The structures are still there, mass, remnants, the accumulated material of every star that ever lived, but nothing is burning anymore. The story of stars has closed. Something else, something longer and darker and much quieter, has begun to take its place. The remnants are still there, and for a long time this matters. When a star like the Sun finishes its life, it does not vanish entirely. It leaves behind its core a dense, slowly cooling object roughly the size of a planet that packed with the mass of a star, no longer fusing anything, no longer generating heat from within, simply holding the warmth it has and giving it up, degree by degree, into the surrounding dark. These cooling remnants of smaller and medium-sized stars are called white dwarfs, and after the last red dwarfs have gone out, the universe is full of them, scattered through every galaxy like cooling embers raked across an immense hearth. There are also the remnants of larger stars, objects even denser, the collapsed cores of suns that ended more violently, so compressed that the very atoms inside them have been crushed together into something almost unimaginably tight. These cool as well in their own time. On the imagined world, the sky has changed beyond any earlier comparison. There is no sun. There is no warm red point of light that rises and moves and sets. What light exists arrives faintly and from great distances, and it is not the light of fire. The white dwarf remnants scattered across the galaxy still radiate a dim glow, a pale warmth leaking outward across the void, and from a dark sky on that imagined surface, some of them might still be visible. Not as the brilliant, scintillating points that once filled the night, but as something softer, cooler, a handful of faint presences distributed unevenly across a darkness that is now the dominant condition of the sky. Over time, even this fades. The cooling of these remnant objects is extraordinarily slow, but slow is not the same as stopped, and the universe at this point has time available in quantities that make every previous era seem brief. A white dwarf releasing its stored warmth into empty space does so over timescales that stretch far beyond the current age of the universe, beyond any number that carries easy meaning. But stretched across enough of those years, even the dimmest, most patient glow gives out. The remnants of stars cool through orange and then deep red, and then a warmth invisible to any eye, and then they are simply dark, no longer glowing by any means, just cold, dense masses drifting in space. The imagined world's sky grows darker in this way, not through any single event, but through an accumulation of individual, quiet extinguishings, each one separated from the last by an interval so long it contains multitudes. What this era is named for, the Degenerate Era, refers to the particular physical state that matter falls into when it is this compressed and this cold, a state where ordinary atomic structure has given way to something more fundamental and tightly packed, and it is the dominant state of most of the matter still remaining in the universe. The galaxy is not empty. It is full of dark, cold, dense things, the remnants of stars, the remnants of remnants, drifting in formations that still trace the old shapes of galaxies, still held loosely in gravitational relation to one another, still describing a wheel, though a wheel that turns now in complete darkness. On the imagined world, there is still ground underfoot, still stone and sediment, and the long accumulated layers of a geological history. There is still the structure of matter holding itself together in the ordinary way. Atoms bonded, surfaces solid, the physics of everyday objects still intact. But ordinary matter, as it turns out, is not permanent in the way that everyday experience suggests. The particles that make up atomic nuclei, the small, dense centers of atoms, the cores around which electrons have always orbited, those particles are not eternal. Given enough time, they too release themselves. A single such particle in the nucleus of an atom will, at some point across a span of years, so immense that it requires stacking powers of 10 in ways that lose their meaning for ordinary intuition, simply decay. It transforms. It releases a small amount of energy and becomes something else, something lighter, something that drifts away. This does not happen to all such particles at once. It happens to one here, one there, scattered across the matter of the universe, according to something like chance, with no urgency and no coordination. Stone on the imagined world releases itself not through melting or weathering or any process that could be watched. A nucleus decays somewhere inside a grain of mineral, releases a whisper of energy, and the grain is very slightly different from what it was. This happens again, and over timescales that exceed the cooling of white dwarfs by many orders of magnitude. The stone itself is quietly dissolving into simpler constituents, releasing whatever remained of its warmth into the surrounding void, until what was once solid is no longer there in the same form. There is no drama in this. It is not a crumbling or an explosion or a transformation that any observer would register across any reasonable span of attention. It is simply the universe's matter completing a long-postponed return to simpler states, particle by particle, grain by grain, over durations that make the age of stars seem like the first few moments of a long, long night. The galaxy still turns. The cold remnants still drift. Gravitational forces still exert themselves, and occasionally two cold remnants will drift close enough to feel each other and slowly spiral inward, merging over eons into something more massive, releasing a little energy in the process. The universe at this stage is not motionless. Motion never fully stops while there is mass and gravity. But the motions have become so slow, and the distances so vast, and the events so widely separated in both space and time, that the texture of the era is one of overwhelming stillness. Between events, there are stretches of nothing. Or rather, there are stretches filled with space and cold and slowly cooling objects and the faintest possible drift of particles, but nothing that interrupts the quality of quiet that has settled over everything. The imagined world, cooling alongside all the rest of the matter in the universe, growing quieter at every scale, receives no light from any direction now. Whatever sky it has is as dark as space itself. The stars are gone, the embers of stars have cooled and gone dark, and the structures that composed it are, very gradually, releasing themselves into the wider universe, not with force, but with the unhurried patience of something that has all the time there is. This is what the Degenerate Era is, a time of extraordinary duration and extraordinary quiet, in which the accumulated material of 10 billion years of stellar life slowly releases its final warmth and its final coherence into a universe that has grown very, very dark and very, very patient. What energy remains is spread thin. What warmth remains is dispersed so widely that no single place holds more of it than any other. The old structures are cooling, dissolving, fading, not suffering, not resisting, simply completing what the first formation of stars set in motion such an unimaginable distance ago. And still, at the end of all this, after the white dwarfs have gone cold, after the denser remnants have given up their warmth, after the ordinary matter of stones and surfaces and the compressed cores of dead stars has released itself into simpler forms, there are things that remain. Not stars, not remnants, not ordinary matter in any recognizable configuration. Something else. Something that formed long ago from the densest, most concentrated gravitational collapses the universe ever produced, and that neither cools nor decays in the way that ordinary matter does. The dark is not yet finished with what it holds. They are not stars, they never were quite, though they grew from the same catastrophic abundance that gave the universe its first light. What remains now, in this era so remote from the age of ordinary matter, that the span of all previous history looks like a brief preface, are structures held together by gravity alone, not by the heat of fusion, not by the pressure of particles pushing outward against collapse, but by the sheer concentrated curvature of space itself, folded inward around a point of density so extreme that nothing, not light, not any form of energy, passes back out through its boundary under ordinary circumstances. These are the black holes that formed when the largest stars ended. Some formed when entire collections of stars, drawn together over billions of years at the slow rotating centers of galaxies, merged and accumulated until the mass at the core became something the rest of the universe could not reach. They are not dark in the way that empty space is dark. They are dark in the way that an absence is dark, a region where the usual rules of presence and distance have simply stopped applying. Around each one, space curves toward an interior that cannot be observed from outside. They do not flicker. They do not pulse. They simply are, as they have been for longer than stars existed. And yet they are not perfectly, eternally sealed. There is a process, subtle almost beyond expression, by which a black hole loses itself, slowly, over timescales so vast they dwarf even the degenerate era that preceded them. It arises from the nature of empty space itself, which is not quite empty, not in the way the word suggests. At every point in the void, pairs of particles are briefly flickering into existence and annihilating each other again, a constant, restless foam at the very bottom of what exists. Near the boundary of a black hole, where the geometry of space is most severely curved, these pairs occasionally separate before they can recombine. One particle falls inward, and the other escapes into the surrounding darkness. To a distant observer, if any existed, the black hole would appear to be very faintly, very slowly radiating. Not burning, not glowing in any way that resembles a star, but breathing out, particle by particle, in a process so gradual that the word slow becomes almost meaningless in this context. This radiation is extraordinarily cold. The largest black holes radiate at temperatures so far below anything measurable in ordinary experience that the distinction between their temperature and absolute zero is almost philosophical. A small black hole, one that formed from a single stellar collapse rather than a galactic accumulation, radiates slightly warmer, though warmer here means something almost impossible to communicate, a difference measured in fractions of a fraction of a degree above nothing. For the enormous black holes that anchored galaxies, the exhale will be so slow and so cold that the universe must wait through periods of time that have no analogy in any previous era before even a small fraction of the mass is returned to the surrounding space. On the imagined world, there is no sky in any familiar sense anymore. The atmosphere, if it persisted through the degenerate era, has long since released its constituent matter into simpler forms. What remains of the ground is whatever particles have not yet found their way into dissolution. But setting aside the question of what the world itself has become, there is still the question of what surrounds it. And in this era, the answer is a darkness so profound and so uniform that the glow of the nearest black hole would be the only interruption in the field of view, if field of view still meant anything. That glow is not a light that could be seen with anything like ordinary sight. It is so faint that it would fall orders of magnitude below the threshold at which ordinary matter detects radiation in any useful way. And yet, it is there. Spread across the sky in every direction, from sources separated by distances that stretch beyond anything with a practical name, there is the faintest conceivable warmth. Not a warmth that heats, not a warmth that illuminates in any visible sense, but a warmth in the strict physical meaning, a temperature, however fractional, above the background. And the background itself is not quite zero. The ancient afterglow of the very beginning of the universe, the faint thermal radiation that filled all of space in the earliest moments after the first expansion, has been stretched by the growth of space itself to wavelengths so long they are nearly impossible to distinguish from stillness. But they persist, these last whispers of the original heat, thinning and cooling as space continues to expand around them, falling toward a background temperature so low it would take a number with more zeros than the human mind was ever built to hold. The black holes sit within this background, warmer than it for now. Not dramatically warmer, not warmth in any living sense, but warmer. A very large black hole will not begin to evaporate noticeably until the universe around it has cooled to roughly match its own extraordinarily low temperature. After that threshold is crossed, the balance shifts, and the slow exhale becomes the dominant process. The black hole begins, in the most glacial possible way, to give itself back. A small black hole finishes first. As it loses mass, the process accelerates very slightly, then more so, not explosively, but with a kind of structural inevitability. Less mass means a slightly tighter geometry at the boundary, which means slightly more energetic radiation, which means faster loss, which means less mass again. The whole process tightening over spans of time that still measure in the trillions and quadrillions of years until a final, brief, quiet release of the last energy returns whatever remained to the surrounding void. The great ones at the centers of old galaxies will take far longer. Some will hold themselves together through periods so extended that a single tick of an ordinary clock at the beginning of the universe, 1 second in the first year, is to that entire duration, as a single second is to all the time that has already passed. They sit in their darkness, imperceptibly warmer than the expanding void around them, giving back particles one by one, and the universe waits with the patience of something that has forgotten it was ever in a hurry. The imagined world, or whatever form the matter that once composed it has taken by now, drifts somewhere in this context, perhaps scattered, perhaps still loosely associated, whatever atoms survived the Degenerate Era, now moving very slowly through a space so large and so cold that the distance between any two of them is effectively infinite for any practical purpose. The glow of the nearest black hole falls across whatever is there, at a temperature too low to warm anything in any meaningful way, and yet present, a last organizing principle of the remaining universe, the last structure that has not yet released itself completely. And then, over durations that the narration can only gesture toward, they do. One by one, in order of size, from the smallest to the most immense, the black holes give up what they hold. The exhale that began so quietly, so gradually, so far beyond any possible witness, reaches its conclusion. Not a collapse, not a catastrophe, not a dramatic ending. Simply the last of the particles returning to the space they once helped to curve, the glow fading to nothing, the boundary dissolving as the mass that defined it is finally fully gone. And after that, for the first time in the entire history of the universe, there are no structures left. No gradients remain, no pools of warmth against a cool surround, no eddies of density in a thinner medium, no whisper of movement along a pressure difference. The universe has arrived at what physicists call its final state, and it is this, everything the same, everywhere, all at once, with nothing left to change. The imagined world, which has served as a place to stand through all of this, dissolves here too, not violently, but simply. Its matter long since having followed the same patient logic that claimed every other structure, every other arrangement of atoms that once held together by the old rules. The sky above it requires no witness now. The sky above it is the sky everywhere, which is to say it is nothing so particular as a sky at all, only the same undifferentiated dark extending in every direction without edge or center or meaning of scale. What persists are particles of the simplest kinds. Electrons and their antiparticles, photons of light so stretched by the vast expansion of space that they have nearly no energy left, the occasional neutrino, almost massless and utterly without company. These drift. That is perhaps too animated a word, but no better one exists. They move, in the sense that they continue along whatever path they were on, but there is nothing to encounter, nothing to deflect them, no gradient to follow or resist. The distances between them are so immense that a single particle might travel for durations longer than the entire history of everything that came before without passing near another. There is no temperature to speak of, in the sense that temperature is a measure of how particles are moving relative to one another, some fast, some slow, a distribution with a shape and a peak. Here, in this final state, that distribution has flattened completely. There is no fast and slow anymore, no hot spot and cool region, no anywhere that is different from anywhere else in the way that would allow heat to flow. Heat flows from warm to cool because those differences exist. When they are gone, heat has nowhere to go, and so it goes nowhere. And so, in a very deep sense, it ceases to be heat at all and becomes only the ambient texture of a universe at rest. This is what is meant by maximum entropy, the condition in which no further change is possible, not because something is preventing change, but because change requires difference, and difference is precisely what has run out. A universe at maximum entropy is not frozen, not locked, not held still by any force. It is simply without reason to be otherwise. Every arrangement that could be reached, every distribution that could spread, every energy that could flow downhill has done so, and what remains is the bottom of every hill, simultaneously without exception. There is a certain completeness to this that resists the language of loss. Nothing has been taken, nothing has been extinguished against its will. Every star that ever burned spent itself in the direction of this equilibrium, and every black hole that ever gathered mass and curved the space around it was, in its way, one long step in the same direction. The universe did not fail to hold together. It held together for an almost unimaginable span, and then, having done everything available to it, it arrived here, in the way that a river arrives at the sea, not stopped, but finished. The imagined world and its patient sky, which served so long as a place of witnessing, merge into this without ceremony. The atoms that would have composed its stones and its air and its slow blue atmosphere are indistinguishable from everything else now, their identities dissolved not by any catastrophe, but by the gentle arithmetic of vast time. Matter, at scales small enough and given spans long enough, does not hold its form forever. The bonds that once made one thing distinct from another belong to a universe with energy gradients, and those gradients are gone. What the darkness looks like from within is a question with no meaningful answer, because looking requires a viewer with a metabolism, a chemistry, a difference between inside and outside, and all of those things required what the universe no longer has. The darkness simply is. It does not look like anything. It does not feel like anything. It extends. Photons cross it, single and unhurried, each one a remnant of something that once happened. A star's surface, the glow of a cooling object, the faint warmth that leaked from a black hole across uncountable ages. But even these are nearly indistinguishable from nothing now. Their wavelengths stretch so long that they carry almost no information, almost no energy, almost no mark of the events that produced them. They are like the last vibrations of a sound, thinned past the edge of hearing, traveling outward because traveling outward is simply what they do. And the universe holds all of this, gently and without preference. It does not strain under the emptiness. It does not lean toward anything. It simply continues in the only way a universe at maximum entropy can continue, which is to say without change, without direction, without beginning or end to any particular moment. One instant is identical to the next. The arrow of time, which pointed so clearly through all the ages of stars and cooling and evaporation, has no content left to point through. The distinction between before and after requires that something be different in one than the other, and here nothing is different. The imagined world sky is this sky. Every sky is this sky. There is only one condition left in the universe, and it is everywhere at once, and it is still. That stillness does not deepen, because it is already complete. It holds the way a surface of water holds when no wind has touched it, and no stone has fallen in, not frozen, not empty, simply resting at the lowest energy it can reach, needing nothing, losing nothing, perfectly itself. There is a quality to this condition that is difficult to name, not because it is complicated, but because language was built by beings who lived inside change, who needed words for movement and transition and the difference between this morning and the one before it. The universe no longer has use for most of those words. What remains is closer to the feeling of a breath that has been let out all the way, not held, not taken again yet, just released, the chest quiet, the body at ease, the moment suspended without effort. The particles that drift through this dark do not know they are drifting. They carry no memory of the stars they were once part of, no trace of the long cooling, no remnant impression of the light that crossed such distances once in an earlier age. They are simply there, and then a little further along, and the word further no longer carries much meaning because there is nothing to be further from, no landmark, no gradient, no warm region and cold region to mark the difference between here and there. The geometry of the universe is vast beyond any number that would be comfortable to speak aloud, and yet every part of it is the same as every other part, and so the vastness and the smallness are equally meaningless, equally fine. This is not absence. It is important to hold that gently, the way one holds a word one is not quite sure how to use. The universe is not empty. It is full of everything that was always going to be left at the end of all the burning and the cooling and the long, slow evaporation of the last black holes. Nothing has been lost in any absolute sense. The matter that became stars became gas, that became new stars that became white dwarfs, that became cold, dark things that became, over immensities of time, simpler and simpler arrangements of their own components, and those components are still here, or their descendants are, scattered and slow and at perfect rest. All that was ever here is still here, only spread, only still. The imagined world was always a placeholder for this. From its first quiet field under a sky full of light, to the long dimming, to the dark, it stood beneath as the last faint glow of the last black hole finally ceased. It held the shape of a place where a consciousness might rest and watch. There is no longer anything to watch in the way watching requires. And so the world completes its purpose simply by dissolving into the same condition as everything else, not violently, not with grief, only gently, one threshold crossed so slowly that the crossing cannot be located, the way sleep arrives, not at a particular instant but somewhere in the soft country between one breath and the next. The sky it stood beneath is still a sky, in the sense that the space is still there. The space goes on in all directions without boundary, uniform and dark, and neither warm nor cold in any relative sense, because there is no relative sense left. It is the temperature it is, which is the temperature everything is, which is the only temperature the universe now knows. Somewhere in that dark, something that was once light continues in whatever form it takes after so long a journey. It does not illuminate anything. It does not strike a surface and scatter. It moves, if moving is still the word, through a medium that neither resists nor welcomes it, and the universe neither notices nor fails to notice, because noticing has no mechanism here. The silence is not waiting. That is the thing about silence when it is this complete. Waiting implies that something is coming, that the silence is a container for the next event, that time is moving toward a destination. Here the silence has no such orientation. It is not the silence before a sound. It is not the silence after one. It is simply silence, whole and sufficient, requiring no resolution. And so the universe rests. Not in the way that a tired thing rests, not in the way that rest implies recovery or preparation, not in the way that rest is a pause inside a longer story. It rests the way a thing rests when it has arrived at the only place it was always going, when every gradient has been smoothed and every difference has been honored and spent and allowed to even out, when the long, beautiful, complicated, burning middle of everything has given its energy to the whole, until the whole holds it equally, everywhere, undivided. There is no clock left to measure how long this has been the case. There is no observer to feel the duration. There is no warmth anywhere leaning toward the cool, no cool reaching toward the warm. There is only this, distributed and quiet and without edge, the final note of a long composition held so long that the distinction between the note and the silence around it gradually, and without announcement, lets itself go. The universe in its stillness is complete. Not finished in the way a thing is finished when it has been interrupted or exhausted, but finished in the way a circle is finished, containing everything it was meant to contain, closed gently on itself, at rest in its own perfect and undisturbed equilibrium, with nothing left to do and no direction left to fall in, simply here, simply still, simply everything.